Hello everyone, welcome back. Let's start the last talk of the day. Here on stage we have the next speaker, Huhta. He comes from ICEYE, he's a senior security engineer. With almost over 2 decades of experience safeguarding critical infrastructure, he brings a robust understanding of threat modeling, security testing, and secure system design. Currently, his focus on ICEYE is working with the application security team to help developers create and maintain systems safely and ensure that they are using the best tools available for their work in both terrestrial and extraterrestrial operations. He has a great passion for making sure that security is a positive force and loves to push boundaries whenever possible. Well, thanks and I leave you the stage.
Hi everyone, and I would like to apologize. I do understand that I am the last man standing between you and the lovely refreshments. But I also sympathize because I am myself my own enemy. I am also in between myself and the refreshments, and I'm a Finnish person, so I do love to drink. So yeah, I come from ICEYE. A little bit about me. I've been an information security professional for almost 20 years. Not in space, obviously. I've worked in a lot of sectors, in banking, in defense, gaming, in healthcare, all kinds of places. Most of my career has been revolving around offensive security. I've worked in a lot of red teams and purple teams, and also in SOCs, like on the blue team side, and also on secure programming. My first job was in Oulu University Secure Programming Group, and that's how my career started. And I've been trying to keep it along as long as I've been doing this, and it's mostly what I've been focusing on lately as well. So. I am at ICEYE as a security engineer, and you can send me an email if you want, or contact me on LinkedIn. I accept everyone. I know it's some people don't appreciate that habit, but I don't mind. I would also like to thank you, my team. This is our latest picture. That's me and Kata and Steve, our application security team at ICEYE. Also, important announcement. I've been looking at a lot of presentations today, and a lot of them have been like these product presentations, but mine is more about like experiences, personal experiences. So I am showing you a lot of things, but good to keep in mind, not all of them are from ICEYE, so don't make too many assumptions about ICEYE specifically based on this presentation. Also, our IT security is sitting there, so if they make like these angry faces on some of the slides, it doesn't mean that they're angry to me. It's a form of like endearment in Finland when they look really grumpy. And also, no satellites were harmed. At least not a lot of them. So this gets the stamp of approval. Okay, so the question is obviously like, am I just giving you a presentation about the infrastructure as code, which I could give at like some Kubernetes conference or at KubeCon or something like that? The answer is, yeah, I kind of am. There was a presentation in the morning. They asked a question like about secure programming guidelines in space, which was a weird question because, I mean, the guidelines are the same. The programming is the same, so why would it be different in space? But I am going to start in space. So here we are. I am a simple satellite in space. What could hurt me? We started this morning with a wonderful video. I'm having a little bit of a budget version of that. These are the bad guys. They are the notorious hackers. And they have developed a death beam that will take out our satellites. No, this is not it. Our security engineering has never considered this option. And I mean, it's nice, you will get people excited, but this is not a thing. I mean, satellites are pretty, they're pretty good. This might, for example, might be a slide that the IT security won't like. We've had satellites in space. This is X2, it's public information. It's been up 2018, for quite a while. But this doesn't always is the case. So it's also public information when satellites don't stay up. I mean, it still might get back up. I'm not saying it has crashed because ICEYE doesn't publicly announce these type of things. So it might just be a flesh wound. So these type of things do happen. Satellites do come down. But why? I'm not going to tell you why, but there are reasons. Okay, so what is the immediate threat? Okay, I could go the highway and like Ukraine has said that, I mean, yeah, space is no longer the future, it's the front line. But I'm not going to go there either, because there's a more pressing concern. This happened some time ago, not like yesterday or last week, but Eric Jensen, our CEO of US, said, well, now we have the capability to do 25 centimeter products, which is nice. But then we got this guy, Joe Morrison, saying that if you're willing to add those images to a public data bucket somewhere, let's review it. And then someone said, let's do it. So this is the type of thing that is probably more on our alley, actually. So we need to do these type of things. But what it actually means, we have to build a lot of machines, send them to space. We need to have some sort of like domain expertise that other people don't have. We need to do software fast, and we need to have adequate security. That is what the business people like. They don't want like extreme security. They want adequate security. So how do we develop fast? We automate. And that's how we get to infrastructure as code. Because that is how you automate things. That's how you deploy things automatically and do things fast. So actually our presentation is more about this guy. And now we will talk about security. Well, kind of, but no. Because first we will look at history. The ancient times. In 1960s, this could also be called the Iron Age. The heroes were make, shell scripting, until we got to the ancient civilization of 2000s. The virtualization era, there were VMs. The heroes were Puppet and Chef. They helped reconcile these VMs and did the so-called, it wasn't called infrastructure code yet, but this is kind of infrastructure as code. Until we actually do get to the modern era. I made this picture with AI, and I looked at all of the pictures. They all have 5 fingers. But this is an extra arm. I noticed. Okay. This is the start where it actually starts. So the heroes are Ansible, Terraform, Docker, Kubernetes, stuff like that. And I will very quickly talk about the space era. This is not the focus, but maybe in the future we will have infrastructure as actual code. Then we have like OpenTofu, Pulumi, and stuff like that. But this is kind of like the current era, how we do things now. Or, I mean, a little bit more modern, maybe. So, why infrastructure as code? We need to have these type of things. But more importantly, actually, we need to reduce human error. That's the main component. We also need to have consistency. We need to have better disaster recovery. Infrastructure as code helps us like build stuff back up quickly. But yeah, security as well. So, quickly, what is infrastructure as code? You all know this, but just quickly. So I'm mostly talking about like the Terraform side of things, so HCL, but there's other ones as well. Terraform, Obviously, you can use it to other things than just the cloud or Kubernetes and stuff like that. We deploy on on-prem systems. We deploy in all kinds of things. For that, the Terraform world has this thing called providers. So you can download providers that will interface with the thing that you are trying to automate. There's also an important thing called state files, which means that the infrastructure as code will build the state, which is like the master data. It's the snapshot that it's comparing the new code. So that is a very important part of it. Access rights and configurations need to be in place, and you have kind of like has this plan deploy type of cycle. You plan, which means that you will compare your current code against the state files, and then there's deploy that will actually deploy the state file into production or whatever. So what are the actual threats then? The supply chain attacks, obviously, not just the container images, but for example, the providers. It doesn't take a lot to be an official provider. And then if you are a provider, you can basically just squeeze yourself in. There's obviously like privilege escalations and stuff like that, and intentionally malicious code. You can have dangerous like misconfigurations. Some people might deploy code that is dangerous to production. It's kind of like the picture that you see, but in more realistic terms, we have the coder here. We have the developer. What is he doing? He's using GitHub, just an example, as a repository for his infrastructure as code. He will copy all kinds of stuff from the internet to create what he wants to do. He's using his console to push things to, let's say, AWS or Azure or whatever. In order to do that, obviously, he needs access rights. He needs the sufficient access rights to do these type of updates to the systems, which are stored probably in some key safes. There might be Rancher. He needs access to Kubernetes kubectl access rights. So he needs all sorts of accesses to run the actual Terraform. And obviously, he needs access to the state file, which is usually stored externally somewhere, like in AWS S3 or something like that. Okay, I will call this level 1. I will also call it the Indiana Jones way, because it means you will put on your fedora hat and you put your whip on and you go. Because the thing with this approach is that when you have more than one developer, then obviously you need to have a way of working together with the repository. They all need access, and they usually share the same state file buckets as well. This is how things start. I will be very surprised if your developers haven't gone through this phase first, because there's a problem with this approach as well. Security problems. The state files. They are the treasure. They have everything in them. Obviously, these access rights are very powerful. If you get access to the access rights, you don't need Terraform. You can just use them. And in many places, you need to have some sort of secrets for the applications. And in many cases, you store them in GitHub. Hopefully not in plain text. Sometimes it's in plain text. And you might think, okay, well, I mean, I can work with this. I can use some sort of like secret manager. I will store the secrets in a secret manager, and I will refer to them in the code. Now no one knows the secrets. Here's the problem. You might use some sort of like an secrets manager to do this, but do you know what happens here? Who knows? They get stored in plain text in the state files. They are stored securely in the key management system, but here they are accessible. And you need access to the state files because you want to run the Terraform. So there's a way to do this. I mean, you could just like sync the secrets directly into your end systems, but this This is just something that doesn't really happen. So you need to get rid of this. And one way to do it, again, this is just one example, is that you will rely more on your process for the regular code development. You might have good practice for access rights in your repository and like good pull review stuff, and you're not allowed to commit to main branches, and you have all the things in place. So there's some sort of like acceptance criteria. You will test the code, you will run all the functionality tests and stuff like that. And then you will run plan, and then you will deploy. But not on the actual Terraform. So you'll have some sort of system in place. You can use Atlantis. You could use Spacelift, since it's a space company. You could use Terraform Cloud, stuff like that. But some sort of like external system, which will actually do the planning, and will actually do the deploying. So you don't have access to these things anymore. And a nice thing as well, that it will also dictate that you're not allowed to do certain type of things. It will prevent you to do these dangerous things with the code. And it will handle all the integration, so you don't give access to developers to the critical systems. I would call this level 2. So, what will happen when you're in level 2? In many cases, something will happen. Your code base will diverge. They will become application code, and then like this deployment configuration code. And once you have these things in place, there are gatekeepers that want to take care of these things for you. There will be us, the security engineering. There will be people like SRE who want to impose observability into the Terraform. There's infrastructure automation that won't allow you to do things unless they are done their way. So they will become this wall. And we call this developer platforms, which is nice. It's a nice thing. Instead of allowing the developers to run Terraform code, you will offer them services. You will say, click this button, you will get the database. Click this button and stuff will happen. So it goes like this. Level 0, you don't have any infrastructure as code. Level 1, developers use code from local machines. Level 2, you use CI tools. And level 3, developers don't know about infrastructure as code. Obviously, it's not that easy. There's reasons why this won't happen. I mean, Terraform will have like these things called feature lag and stuff like that. So it's a pipe dream. And actually, this is my final slide. So this will include a lot of things. It's kind of like this load balancer. So I can go through this quickly, and I can go through these slowly. So I will go through this pretty quickly, since I want to get some drinks. These are all the kind of things that you need to consider when you're doing infrastructure as code. I would like to mention that in this today, I have heard AI mentioned 5 times. So this is the 6th time. Sorry. I've heard blockchain mentioned twice, and I've heard quantum mentioned 7 times. That is a lot. But yeah, I mean, generative AI is a thing. So if you're actually allowing your developers, and you should allow your developers to use generative AI, you need to consider that they're also using it for infrastructure as code. Yeah, I would like to highlight the policy as code as well. It's an excellent thing. Depending on your platform, you can implement the policies as OPA policies, or you can use Sentinel if you use Terraform Cloud. And there are readily available policies that you can just copy to your system. And I would also advise that you will gatekeep this. So for example, the security engineering will decide if there's new policy as code approved. So for example, this is good for the providers. So you can whitelist the providers and say that only the security engineering can approve new providers. Okay, 3 things. I would like you to think about protecting state files. This is very important and it's often overlooked. I would like you to not be afraid of change. This might sound like, oh, infrastructure as code is so horrible, but no, it's a great thing. It actually does make things quicker, and it is a good thing for security. And also identify the sensitive deployments. You can actually restrict what the Terraform is doing, and you can kind of like be very specific about the access rights. So it's very important that you kind of like know where you're using the Terraform or whatever infrastructure as code you're using. So yeah, that is my presentation. I have 40 seconds left until I'm ready for questions.
Thank you very much, Jyri, for the presentation. Luck that you said that you didn't have any joke in the presentation, so yeah.
No, I explained that my sense of humor was amputated when I was young, so I'd like to apologize.
Well, any question in the room? Oh, perfect.
Yeah, first, thanks a lot for your presentation. I think it was funny and also very relevant for those who are using actually Terraform. My question is about like, you didn't mention, I mean, the level 2 was about like using Atlantis and directly like deploy through the GitHub. But what about like, it's a bit like compiling code, but not testing it, not running it. Like if you just check that your plan is working, but your Terraform deploy, it didn't actually deploy, you could still like have issues. So how would you advise like developers who are coding on their own to try this? On our case in SkyNP, we are like using a completely like testing environment to do that. But I don't know if you have another solution for that.
Yeah, I mean, on the level 2, obviously, there's lots of options that you can improve. So, like I said, on the pull review phase, you can be very specific that you are not allowed to, because, for example, Atlantis, it doesn't allow you to do the deployment until until the pull review is accepted. So you can have all kinds of steps in place where you are mandating that the linters will have 0 findings, and you can have all sorts of things there. And then it's only allowed to deploy. And on the Atlantis side, again, you can use the policy as code to prevent stuff from.
But so it means that your iteration loop is can be long. I mean, if you are waiting for like your pair to be reviewed before you can try to apply your Terraform.
Yeah, that's true.
Like, okay, and you are just like accepting this iteration loop and saying, I mean, that's okay to wait for the pull request to be reviewed before trying to deploy, even if it's not in production. Obviously, I mean.
Yeah. This is obviously for production. So the thing that is usually required is that the developer should have access to good development environments where there's like less.
Okay. Thanks a lot.
Any more question in the room? Oh, perfect.
Thank you. First of all, thank you very much for the very inspiring presentation and very nicely done. I mean, this is really nice. Second thing I would like to ask, because you speak about infrastructure as a code, could you a little bit elaborate what infrastructure you deal with as ICEYE?
Well, again, the IT security is there. They will look at me endearingly if I tell you too much, but yeah, we do use cloud a lot. We use Kubernetes a lot, and then there are like on-prem environments. But mostly those on-prem environments are also designed similarly to the cloud environments. So they rely on the same type of technologies. So for us, those are the main use cases for infrastructure as code.
Okay. Any more questions in the room?
Mm-hmm.
Okay, thanks, Jyrki. That was really interesting. How do you see this working with flying satellites? And because this applies very well for ground software, but for the satellites, and what are the special considerations regarding that?
It is a very good question, and I would love to have an answer for that. We've been playing with the idea that everything should be as automated as possible, but obviously the satellites do have components that we don't want to expose to the full automation. But there are things that you can do with infrastructure as code in satellites as well. So for example, you might have like this like upgrade cycle where your user land software is updated with infrastructure as code, and then you can like remove the human component, because you do have to update the software in some way. So the options is that you will have like a manual process of doing it, or you will have an automated process for doing it. So especially for like this patching type of jobs, it might make sense to use some sort of infrastructure as code. Maybe not Terraform, but some sort of like automated way of doing it.
Thank you. Any more question? Okay, then perfect. Thank you again to the speaker. And